There's no doubt that AI is changing the way we live and work, aiding us in routine tasks to solving complex challenges. From using AI to consolidate travel plans to using chatbots as career coaches, the opportunities are boundless, and that's just with large language models. But things are a bit different in medicine. From helping with pixel-based tasks like classifying findings on diagnostic imaging, or aiding with predictive analytics for patient outcomes. But can AI be our greatest ally in the years to come? Is there a single best way to interact with AI results? And if not, what are the emerging paradigms for human-AI interactions? And at what point is it too much AI to where the efficiency gains and diagnostic gains are overshadowed by added cognitive burden? These are a few of the questions that arise as we continue to see an increased adoption of AI in healthcare. We need an expert to help navigate these complex topics. Fortunately, I think we found just the person. I'm your host, Ali Tejani, and this conversation is part of a special AI video series presented by the AJR, where we host multidisciplinary conversations about some of the most pressing topics surrounding AI in medicine with thought leaders in the field. Dr. Pranav Rajpurkar is a co-founder of A to Z Radiology AI and associate professor at Harvard Medical School. A Stanford-trained computer scientist, he develops AI systems for comprehensive medical decision-making. His 130-plus academic research papers have garnered over 39,000 citations and recognition from MIT Tech Review, Forbes 30 Under 30, and Nature Medicine. Dr. Rajpurkar, it's great to have you here. Is it okay if we continued our conversation on a first-name basis?
Yes, that'd be great. Ali, thank you so much for having me. And it's great to have the opportunity to have this very exciting discussion with you.
Absolutely. And that sounds fantastic, Pranav. To be honest, we're going to try and cover as much ground as possible, but you may have to be selective in how much we can talk about some of those exciting topics that have come up in our circles and in our conversations as well. But to start out, thought leader, scientist, associate professor, and entrepreneur, you wear quite a few hats. And you're not a radiologist by training, but when I first met you, I thought you were a radiologist because of how closely your work is related with medical imaging. Can you tell us more about how you found yourself working with medical imaging and radiology?
I love it when people think that I'm a radiologist, and I feel flattered when that happens. So I started working on AI for radiology and more broadly medicine in 2017. And at the time I was doing my PhD at Stanford, and I'd spent about 5 years working on AI, preliminarily within the context of autonomous driving, and then within the context of medicine. And what amazed me so much about medicine, and in particular radiology, was that it was clear that between where we were in terms of the use of AI in a field versus where I saw parallel fields and the level at which they were using and benefiting from AI, I realized that there was this vast chasm and delta to be filled. And so fast forward now 8 years later, I think it's that journey that's taken me through being a scientist, graduating from my PhD, starting as an assistant professor, and then now also an entrepreneur. But if you asked 13-year-old me what I wanted to be when I grew up, you would have heard scientist. And I had this copy of science books like Eminent Scientists, I remember was the title of one of them. And so being inspired by these stories of scientists, I always imagined that it would be pretty fun to be in that role. And that's turned out to be true.
And so your research has examined how AI impacts radiology workflow, particularly how AI results influence radiologist performance. What's the consensus so far? Do we see that AI always augments performance, and is that universal across use cases?
There's a kind of study that I like to do and I like to return to over the years because the results keep evolving over time as the underlying technology is changing. And I think as an illustration of the point, let's take up the example of utilizing ChatGPT to be able to help with writing. So before the launch of ChatGPT, there were writing assistant tools that we all used that were called spell checks and grammar checks. And we used them to be able to make phrase level edits, but we'd never rely on that technology to be able to actually help us write or edit. And then soon with ChatGPT in November 2023, people started using these tools to be able to draft emails. Certainly, I use them to help me draft a lot of things. And emails in particular, I wasn't very fond of, because the way every email started was, I hope this email finds you well. And I've never certainly written an email that says, I hope this email finds you well. But fast forward 2 years later, it's very clear that these systems are at a level of capability in which it's not just their ability to assist very highly that I can rely on, but their ability to also do things that I myself would not be able to do. And as an example of this, consider maybe a math problem that I couldn't solve, but I'd be able to follow and at least verify the correctness of. And so I could just have this thing solve a math problem I couldn't have done by myself, and be able to look at it and be able to look at a solution and be able to convince myself that the solution is right. So in this case, we're thinking about a very different kind of what I would call still collaboration, but I would not use the word assistance. And so then bringing this into our world of radiology and how people are benefited by AI algorithms, I like to look at a study, or a kind of study that we can do with this Pixel AI. So there is an AI model that can look at an image and that can come out with a prediction. And then we can have people look at those predictions and determine what they consider to be their opinion of what's going on in the image. And that could be, do I consider this image to have a lung nodule if I'm told that the AI model thinks there's a 80% probability there's a lung nodule? In that case, it's very clear what you might expect from the output of the algorithm to be truly convinced is if the AI algorithm told you there's a lung nodule, well, wouldn't it be nice if it told you, here's where the lung nodule is? And in that case, the format of interaction, which I expect, is almost point me to the lung nodules. But let's say you had a different kind of a task. Let's say the task was that the AI algorithm said that there is a lung nodule. It's small, but there's a very high likelihood of malignancy. And in that case, it wouldn't help to point to the nodule, but I might want the AI algorithm to tell me what are features of the nodule that make it more than average suspicion for being malignant. And that's the sort of example that can illustrate that different problems require different formats of assistance with the algorithm. But I'm going to come to one of my favorite examples here, and this is an example from my own work, in which you have these malignant lesions, or at least lesions that are determined to be, let's actually flip the example. Let's say the algorithm says, this is a benign lesion. And it says with 99% confidence, this is a benign lesion. And then you show it to a person, and the person says, no, I think this is suspicious and should not be marked as benign. Let's, in fact, call back this patient who's had a mammogram to have a repeat mammogram or a diagnostic mammogram. And turns out if you follow this patient for a year or 2 years, it will, in fact, turn out to be a negative. And the human was suspicious for reasons that potentially the AI understood were the wrong reasons for the suspicion. So it's a great example of where this idea that we can improve over the AI algorithm's output with whatever pattern that it might be finding, that remains to the best of our knowledge unproven. And certainly as the algorithms are getting better, it does raise a very genuine concern for the role of the human in the whole process.
This is fascinating. And, as I listen to what you're describing, and I've read those works as well, I almost hear of this AI as a resident, right? The attending's asking the resident, what are those features that make you worry about this being a malignant nodule? Or, taking in that initial impression and applying those critical thinking, the problem solving that you've finessed over years of training as a radiologist, to put those results into context and to transfer that to a final impression. And this almost sounds like the assisted AI paradigm that you've talked about previously. And so in a recent editorial in Radiology, you and Dr. Eric Topol described paradigms for radiologist AI interactions. And the one that may resonate the most with our audience and our current AI users is that AI assisted model, where AI systems provide the results before the radiologist reviews them during the process of imaging interpretation. Can you tell us more about this model? We briefly talked about it there. But is it the most common model out there that we're seeing in practice at least? Or is there an additional emerging paradigm that may be more present as we start to work more with AI in practice?
So we started to think about this AI as a resident paradigm in 2021. And if you look back at one of the works that we had for radiology report drafting at the time, maybe the second attempt from our group to be able to build a model to do this, the idea was fairly straightforward, which was we're going to replicate almost to some degree the human workflow of having someone who can do the tasks sort of well, but then be supervised by the attending. And that's what we call the AI resident. And in this case, particularly the task of interest was look at the image and draft out the report. And I use the word draft here because we want to clarify that this is not the report that actually gets signed off and sent, but it gets reviewed by the attending who then comes in. You might even think of it as a pre-resident, which is that there's a draft, and that draft is the starting point for the resident. And then the resident's output is the starting point for the attending. And so you can create these almost long chains as long as each part of the chain is scalable, as it is with AI. Now, there were some studies in the space of mammography in particular, and in chest x-rays that started to challenge this assumption that having the person come in after the AI actually led to an improvement. And I'm going to refer to some of my work with colleagues at MIT, which looked at chest x-rays in particular and asked the question, does this idea of having the AI do the preliminary part and then have the human come in and override or put their own supervision on top, is that really the right way to do it? And what we found was surprising. So taking a mathematical lens on this, there is some weight that one should put on the AI, and there's some weight that one should put on oneself. Okay? We can calculate what this weight should be if we have enough data. And then we know the optimal weighting you should have on yourself versus on another entity, which in this case is the supportive AI. And what we found was that people weight themselves and their signal more than they should, and people weight the AI signal less than they should. So this is not automation bias. Automation bias is the opposite problem. Automation bias is when you trust the AI too much relative to yourself. This is what we call automation neglect. And so the fact that we're in a world of automation neglect should worry us, because automation neglect says there is some problem in the way that we have decided to use AI. It was previously problematic if the AI was taking us too far away from the right judgments. Here we're not going close enough to what end up being the right judgments. And that got us to think about challenging this idea of the way we're thinking about the setup of AI first and then have the human, and start thinking about, are there areas in which we should start trusting the AI to do what it's designed to do? Of course, being fairly restricted, and have the human essentially focus on the parts that they can say, I don't need to look at this because I know that this part has been done so well. And I'll give you a human example of this. Certain physicians have assistants who they love. And they say, this assistant, this particular assistant, does their job so well that I never need to double check their work. And this has been established through trust This has been established through training. This has been established through a relationship over a period of time. Of course, the same ideas don't quite translate to AI tools because of their dynamic nature, of their inability to actually take feedback into account as directly as we would with other humans. But this does exist psychologically. And psychologically, what that allows a professional to do is to pay more attention to where they don't have that support. And so that was the idea that led to the work with Eric Topol, part one of which was our New York Times article, and part two of which was our radiology editorial. And we have more parts down the line as we're generating more original data, which basically proposed the following, which is, let's think about collaboration through role separation. And role separation can either look like you do something, you, the AI, do something entirely different to what I do before me, or you as AI do something entirely different to me after me, or you as AI take half of the work, I take the other half of the work, and let's be smart about which half you take and which half I take. And that way, I can be just more mentally clear about doing the work that I have in front of me in a reasonable amount of time with a reasonable expectation of quality. And I think that's such a critical part today, where having spoken with hundreds of radiologists over the past year or 2 years, it's clear that our system, even in the US healthcare system, is at a point at which people are in a position where they have to meet certain clinical demands in a certain period of time in a way that may not always be enjoyable. And I think putting the joy back in a profession by focusing efforts and attention on where it's required and being able to add as much assistance as possible is a way that not only makes the profession more fun, but also more productive at the same time.
There are many different branches through this conversation from this point, but the one that I'll start with here is thinking about now in the reading room, in that same context. It's a busy environment. Volumes are ever so increasing constantly, probably as we speak right now. Two questions then from there. The first being, in practices that are starting to use AI, and it's not always the same. Some places are more willing to adopt those tools and translate to practice. Others are a little more cautious and a little slower to make that transition. But in the standard setting, we may see one AI algorithm, let's say. At that point, the radiologist doesn't really have the choice to say, you know what, I trust this one, but I don't trust that one, and I'll take the results from this model over the second one. They're often in a position where they're presented with the AI results from this model and are comparing it to their judgment, for example. What I've seen anecdotally is there's a honeymoon period almost, right? Where it's exciting, there's AI, and you start to see those, either it's an edge case or more consistently drifting performance. You lose trust in the model and you tend to just ignore the results completely. How do we combat that if our goal is that efficiency gain, right? Is establishing trust in the model and the process of fine-tuning it, reassuring radiologists that, hey, there is a monitoring process, hopefully, and there is a means to improve the performance once it's noted that it's degrading. I think it's hard to try and come back once you lost a radiologist's trust, because for them at that point, it's harder to take time to review results that they already have a preconceived notion will be incorrect, and then to also read the study and then the 5 studies pending. Any thoughts on how to navigate that scenario first?
It's a very real problem. I remember speaking with one of the radiology groups at a center that's responsible for measuring very, very small lesions. And one of their experiences was, as the model from their vendor kept updating, it kept performing better on average nationally, but kept performing worse on their group's data because they were the only ones who reported. There were few of the ones that reported these very small lesions. And that goes to say something about the difference in workflows being a very important piece of the solution, and how it's going to be important to treat this as one would any other product that needs to be high functioning, which is be really close to what the users want and need. And I think that's something which, putting my entrepreneur hat on, I've realized is very important. And that's something that we continue to do, hopefully at a rate that allows us to tackle far more of these issues than we create in a given amount of time. I do want to sort of share one other view on this, which is that in many ways, the technology that is being deployed today in health systems and the experiences people are having in health systems, I think will not be representative of the potential of what's to come in the next few years. And I think a lot of what we are learning will have to be unlearned in order for us to move forward. And I'll give you my bets, and I think these are contrarian bets on what will actually happen. One of these I will credit to one of my mentors who taught a product design class at Stanford. And in particular, one of their views on things was that you want a technology to be so seamlessly incorporated into a workflow that you forget that it even exists. And so this idea that we have to look at all these things that are specific to how the technology came to be, data drift monitoring, it's, not working on these particular edge cases, algorithm A versus algorithm B. I want to bet that these are not problems that are long-term problems for us. They're very real problems. They're very genuine problems, and they need fixes today. But I think the technology will have to get so good that people don't even realize that they're using this technology behind the scenes as part of the profession, as part of the work. And I expect that progression, that blending to happen extremely well as the technology itself gets to a point at which we start to say, wow, this really, really works and this really, really helps, which unfortunately is not the state of the technology that most people experience today.
The design component is something that I think doesn't receive enough attention. You could have the most highly performing model for detecting or triaging or classifying, you name it. But even that model may not translate to meaningful clinical outcomes or even performance gains or efficiency gains or whatever metric we decide to use, right? If it does not integrate seamlessly into the radiologist workflow. This could mean that we're making it harder to find where the actual user interface is. It could be that there are too many clicks involved. You have to copy and paste results into a separate chat box, right? To interact with the large language model. Or you have to send images to a separate DICOM node to have it processed by the model that's living on a different server. There are so many different ways that we've seen this in practice, and maybe it's in the nascent phase still. But is it important to talk about how we present AI results? I think that maybe that's a loaded question. It sounds like it is, right? Whether it's a standalone widget, a separate web-based application, a mobile phone application, or something that's integrated into your worklist or other system. But what are some of the most common means that you're seeing or that we're seeing, and maybe this is the entrepreneurial hat, for adapting that user interface to radiologist workflow?
I think the experience on the ground has been that the integration does not feel seamless, that it feels like another thing, another click, another checkbox to fill out. And that's been part of the disappointment of the experience and in many ways the unwillingness to bet on what's next. If we look at some of the ways in which there has been success, or what are the features of the interface, of the integration that does make something work, it's that people can take their mind off of work. It's not that they are adding more work and burden to their workflow. And an example of this might be the examples that we're actually seeing outside of pixel-based AI right now, which is once things are in the text format, the ability to create summaries from the findings themselves. That's an area where the technology has advanced. It's advanced really fast. And it's also an area where there is currently very different regulatory oversight structures compared to the software as a medical device world, in which case the software development cycles look a lot closer to that of a medical device and a lot less compared to sort of being able to deploy software at software iteration speeds.
And so let's take some more examples and building on this conversation, right? There are foundation models all over the show floors these days, right? If you go to our big conferences, chances are that you'll encounter a startup that's working on a foundation model and at varying degrees of production. And as I see the outputs from these models, I think about, okay, it's initially really exciting. You see multiple findings, soft tissue, bones, different kinds of pathology, and there are bounding boxes around them, and they're all presented to you. And then I get a little nervous, a little bit of anxiety comes in because I think of myself at the workstation presented with this on a busy call shift, for example. Now I'm seeing opportunistic imaging findings. I'm seeing not just the acute findings, but the things that need to be followed up, the incidental findings, the bone density being low, the differences in the visceral fat content versus other baselines. And as a radiologist, now I'm thinking, oh my gosh, cognitive overload, right? All these findings. And there's a finding in psychology literature that the time that it takes to make a decision increases with the number and the complexity of choices that you present to the user. As we think about then the current foundation models and those up and coming solutions, at what point do we say, okay, there is a limit to how many things can be flagged in one given setting for a study?
I think we have to think about what is the equivalent of this that would feel seamless and that would not feel like work. And in many ways, I come back to the AI resident paradigm, which is how does the resident currently interact with the workflow in a way that the attending benefits? And, you speak with some attendings in academic practices and they say, yeah, the residents make me slower, no doubt about it. It's more work than just sometimes reading from scratch. And, on top of that, there's an educational component. And you'll get a substantial fraction of attendings who say, for a good resident, this is quite seamless and just does, in fact, make me faster. And that's for academic radiology. For private practice, people have focus on speeds. Often as a result of the incentive structures. And with them, there's this extreme optimization of the existing workflow such that it takes a lot for something to come in and say, I can make you faster. And I think what most people who are foreigners to the field of radiology don't recognize is how high the bar is to get to a point at which you can start to say something like, I make someone more efficient. And I think this is also true for many fields where people who are operating at the highest levels of excellence often have squeezed out every ounce of what there is to squeeze out in order for their workflow to be what it is today. High performers are high performers because they've figured out where the bottlenecks are and addressed them. And the bar to go to them and say, I can make you even more hard performing is in fact a very challenging position to begin with. So I just want to recognize that that's one of the challenges that is part of the problem formulation. But let me sort of, take a step back and then ask, well, then who would benefit from such a system? Where is the bar lower for us to actually say, I can be more meaningful day one? And I see two opportunities. One of them is training, is just imagine the scalability of training to say, I've got one of the best educators in the country, that's teaching less than a mile from where I'm sitting, and people receive fantastic education and become great radiologists as a result. What would it take for that expertise, that teaching expertise, to actually be applied to first-year residents as they're, coming into the field, or to even attract more people into the field by saying, this is a fantastic way to get you to the very top of your expertise. And that is a place in which the bar is fairly low. You can ask many first-year residents who are starting out, given rotation, how well they do and how much room for improvement there is. And there's a lot of improvement. And then there's the second piece of it, which is, in what areas are we thinking about the alternative not being a person operating without the use of AI, but the alternative is no person doing anything because we just don't have enough bandwidth. And people immediately jump to, the resource limited settings, or people think about developing countries or low and middle income countries as the place where that can be applied. And yes, that's true. That is going to be one of the resource constraints. But I want to sort of take resource constraint with more of an eye of what can we do even within Boston, even within US, which is, can we deploy these things in a way such that it is truly getting to a problem which is resource constrained without pulling people away from what they do really well? So you talked about opportunistic screening. Great. So if we can identify a cohort of 100 patients who should be called for their coronary artery finding, that should place them on some cardiology pathway, and that can be done by a group of people without requiring radiologist intervention. Great. People are happy with that. People are happy with thinking about that sort of deployment. Or consider what happens in the overnight setting. If overnight you don't have in-house expertise to be able to interpret images, and your options are telerad, where you might have an hour or two of turnaround at the time, or you might be able to get an instant flip at understanding, okay, is there some sort of a emergent finding that I can detect right now, and be able to alert the ED physician who would say they're able to look at those images anyways in the first place, but get them to look at it earlier. Then you've addressed a problem where there was a resource constraint, where the alternative wasn't quite the alternative that immediately comes to mind when people think, what is the de facto clinical standard of care?
Would you need a human in the loop, though, in that latter example, right? Especially when we think about our ER cases, and maybe there is a model that's too sensitive and is calling many positive findings. Maybe something is not as sensitive and not calling enough positive findings. At what point is there a radiologist looking over these results and making that next morning phone call saying, hey, I hope you didn't act on this result because it was correct or it was incorrect? Do we see that kind of paradigm, or are there thoughts on that framework to make sure that maybe there's a second set of human eyes on the results in that more autonomous workflow?
I think everything we do is human in the loop by the nature of the world's design, is that no matter what we're doing, we have a human in place to be able to deliver care ultimately and to be able to manage patients. When it comes to the radiologist in the loop part, again, I look at what is the existing status quo in these places. Again, we're talking about now the resource constraint where you don't have a radiologist that's an attending that's able to make the reads at that point, make the calls at that point. Because if we did, then that's not what I call resource constraint. What are your alternatives? Our alternatives are either one, there is a resident who is unsupervised that's very, very nervous about their very first nights, in which they have to either decide, I'm either going to report this one or I'm going to wake my attending up from the middle of the night. Is it worth it? That's the question. that many residents are going to face? Or number two is this something where teller ads reading, they're behind, and then you're going to have your in-house attending come in at 7 a.m. and review the cases to provide a final read anyways. And as is often the case, you may or may not know what to expect in terms of quality when you send it out, or there might not even be the ability to create those phone conversations between it being the case being sent out and your ED physicians that are in-house. So I think all of these, I think you see what I'm getting at, which is that the standard of care is the comparison to make. And what I'd love to see are trials which get us to understand what the delta actually looks like. Is the delta truly zero? Is it positive? Or I think we should be very open to the possibility that it's negative, that it is indeed the case, that you can't have a system which provides more good than harm when deployed in this specific way. We simply don't know at this point.
And I think that as we see those conversations unfold, we'll be faced with several ethical challenges in terms of our patients receiving care with AI, getting better care, getting worse care, are those who have access to AI in the immediate vicinity at in a situation that's not as equitable for others in nearby, maybe more resource constrained areas that don't have AI. I don't know if we have the answers to these questions, but I think hopefully our field is actively thinking about those in tandem with the deployment and growth that we're seeing there too. And as a quick note, as we transition to our next topic in just a few moments, wrapping up that conversation on design and human AI interactions, is it fair to simplify things to say, if you make it hard to use, we won't use it? Is that a reasonable takeaway? Or is it doesn't matter how hard it is to use. If you're in a situation where you have AI deployed, you're going to have to use it because of medical legal concerns, all sorts of considerations. What's that paradigm looking like?
I think it helps to be a little bit idealistic. So let me give you the idealistic view on that. Is if you're not realizing that you're using AI because it's so seamless, then I think we're successful. And I think that's the bar which we should be thinking about getting to. Is what does that world actually look like in which it's so seamlessly integrated, it's invisible?
And we'll save the conversation on user awareness of AI being present in those situations for a later time as well. But before we reach the end of our conversation, I do want to talk more about that trainee piece and the education piece. As you know, there's been quite a bit of discussion lately on the risks of deskilling due to AI use. And a popular paper from The Lancet is making its rounds on social media, raising concerns and the question of reduced performance for endoscopists with continuous exposure to AI when they're performing without AI or in the absence of AI. Now, as a radiologist and as an educator, this is a bit concerning for me because I think about the potential risks of deskilling as our trainees are exposed to a growing portfolio of AI solutions. And in a prior life, there were things that we put into place to make sure that our trainees at my prior role were aware of some of these risks and that there was a balance to achieve. But should we be worried as a field? Is this getting out of control or out of our hands to where trainees may have unsupervised use of AI, where we may not be able to get ahead of that conversation at this time?
I think it's a very real concern. And I think part of what makes me feel rather optimistic about this line of concern is that this is a problem that's been faced every generation. I'll give you a beautiful example from within medicine, which is that of the stethoscope. The stethoscope in its use has faded over time in terms of the skill expected to be able to use the stethoscope effectively. In fact, a lot of the skill has been moved to the newer modality of ultrasound, where the newer generation of physicians will rely on it more just in order to be able to make some of the same assessments. And would we call that a deskilling of the stethoscope? Probably. But at the same time, I would call that an upskilling in places where it allowed us to get to the intended outcome in a much better way of using ultrasound to get at a view of whatever someone was trying to understand with maybe a little bit of a higher resolution. Now, if you're a stethoscope purist, you would say, oh yeah, but there are some lung and heart sounds that I'd be able to tell much better than ultrasound would be able to give me an indication of. And that's going to be true. And I think the same holds true for worlds and AI. And there's plenty across professions to help guide us in this way of thinking. You know, the use of calculators as it related to education in high school, the use of low-level programming languages as the new generation has basically been taught to completely ignore all low-level commands and understanding of how memory works and how RAM and cache works in the world of software engineering. And when you are trying to deploy things at billion scale, how most education that's obtained in the university in software engineering will completely break down and requires a completely reskill of a person's a repertoire of skills. These are all things that have been faced across professions for generations. The thing that, you know, is potentially different this time is the pace at which some of these questions need to be answered. But if there's one thing that I think is a very good human attribute and trait to bet on, it's adaptability. And adaptability at the level of individuals, but also at the level of professions. And that's why in being able to publish works like the ones we do, which are bold and innovative in their claims and saying things like role separation might be the future, that I believe that can positively coexist with the profession of radiology and with the profession of software engineering in a very different way than we know it today, but certainly one that's going to make things more fun and more productive and going to deskill in many ways and going to reskill and upskill in many others.
I really like the idea of reskilling. I think we should make it an effort to rebrand these conversations as reskilling. And I agree completely. I think that as we think about these conversations, we often see hype and very extreme narratives. And I think it's important to temper that with a very realistic and optimistic view, honestly, as you mentioned. And flexibility seems to be key, both for, and not just that there are two practice environments, but for training environments in the academic context and the non-academic context. I think being flexible and adaptable will go a long way for those who choose to do so. Now, as we conclude, I guess the question at hand is, will AI be our greatest ally or our greatest threat in the coming decade? What are some things that we can keep our eyes out for in the coming months?
AI is a powerful technology, and I think, as is the case with many powerful technologies, it is how we decide to use it that determines what kind of benefit or cost we get from it. And I think with the current trend of AI growth, in terms of the innovations, in terms of the focus, in terms of the energy, it's a no-brainer in my mind that we're trending towards a world where intelligence is going to be deeply characteristic of machines. And that is equivalently scary as it is opportunist in terms of what that will mean for us. We have, as a society, valued intelligence as a trait that's deeply human, that in many ways has defined what we consider to be equivalent to social status, equivalent to pay, equivalent to progression, and in many ways has been considered to be something that was untouchable by machines for a very long time. You know, in many ways, the idea was that these math problems would be the first thing to be solved first because they were closest to games, and then would come language, and then would come the art. And the fact that we've been able to do these generative things, which can generate art and generate writing, and be able to challenge what we consider to be within the realm of possibility for advancement, just is something that not only theoretically affects how the world works, but very practically, I think, puts on the question of what does the value of human labor and of human intelligence mean? And how should we think about now this incredible supply of intelligence that is at a fraction of the cost that we use to employ humans? And it's no doubt that this is going to have profound implications for radiology, as it is for pathology, as it is for many tasks which are guided by pattern recognition in many ways, that are guided by language in many ways, as is the case for software engineering and computer science, which have been in many ways about speaking a language that's closer to computers than it is to humans. And of course, what did the computers learn to master before they mastered, or at least at the same time that they mastered language, is, programming languages. And so the whole field of software engineering is itself just in many ways toppling, in many ways being challenged. And I think redefinitions will have to happen of what it means for a person to be performing extremely well, what it means in terms of what kind of expectation we would have in terms of baseline use of AI. And I think these are very real challenges for the next 5 to 10 years, and maybe even more.
Now, in terms of staying flexible and adaptable, I'm inspired to take some of these lessons into my own practice and at least start with updating the way I draft my emails. I have to ask, Pranav, do you use AI outside of work? And if so, what's your favorite use case?
I use AI a lot in my day to day. Most recently, I've been really enjoying the real time video features of some of these tools. So often, I will open these tools that allow me to just take a video of what's around me. And most recently, I was able to help a friend in making tiramisu by, on the fly, being able to pull up my phone and be able to ask a question about, I think it was about mascarpone and how to think about the measurements, and just get a real time feedback while we were all cooking. So there are all of these little ways that bring me joy in terms of the ability to access real time intelligence.
I love that. And thank you again, Pranav, for taking the time to talk to us about your work, providing us the insights and guidance that will serve us well as we continue to experience drastic, I think, growth in this sector and beyond. So thank you again for your time today.
Thanks for the exciting conversation, Ali. Appreciate it.
And to those of you out there joining us for this special series, thank you for watching and listening. We want to hear more about how you're interacting with AI and the challenges that you're facing in your practice. Join us for future conversations and visit the AJR website, where you can access other articles, videos, podcasts, and more content. AI raises some tough questions, but we'll keep asking them. I'm your host, Ali Tejani, and see you next time on the AJR AI video series.